All right, welcome everybody. Today we're going to talk a little bit about how to train your LLM and take it into production. My name's Alan Ho. I'm the VP of Product at DataStax for AI. I focus on building products. Previously, I worked at Google Research. I worked at companies like Apogee and PDF Solutions, and I'm a physicist by training. Tissan?
Tissan Matthew, founder, CEO at SkyPoint. As the slide says, engineer, entrepreneur, worked at Amazon for a couple of years. I've been focusing on AI and healthcare for the last 3 years. Thanks, Alan.
Abhilash?
Yeah. Hi. I'm a principal data engineer at SkyPoint Cloud. I overlook the platform team, which is building the core services around data infrastructure and recently around SkyPoint AI ML infrastructure. So yeah, that's it.
So today we're here to really talk about SkyPoint's journey of how they brought their generative AI app into production. In order to do that, we're going to first talk a little bit about how to choose the right LLM, not just the technology, but what is the right architecture for your generative AI app. Then Abhilash is going to go into the details of how they got their architecture to work for SkyPoint. Tissan will then talk a little bit about why this is important, not just for the technology's sake, but also what is it going to, how is it going to impact society. And then we're going to have a little bit of a best practices kind of conversation. And during the presentation, please feel free to ask questions. As you ask questions, we'll have somebody also in the webinar to answer the questions on the fly through the chat. All right, so let's talk about choosing the right LLM structure, namely, what is the right architecture? So when we think about doing augmented generation, retrieval augmented generation, this is the most popular architecture for leveraging your enterprise data for building your building your generative AI app. We go through several steps before we actually before building your application. So the first step is you want to determine how to what is your agent actually doing? What is your app actually doing? And it's by knowing what you're going to do, then you select what kind of LLMs you're going to use. So, choice of self-managed, the size, etc. One little tip, if you're doing retrieval augmented generation, you might not need the largest LLM out there. Today, there's a lot of very good LLMs that are much smaller and cheaper that are very good at summarization extraction. So if all the data you're going to be using for your generative AI app comes from your database, you don't need a very large LLM. Then you figure out kind of where your data is going to come from. Hopefully, you're going to be sourcing it from Astra DB. Other things you need to think about is kind of the access patterns of it. Then you have to figure out how you actually vectorize your data, and then how you use prompt engineering to call your LLM and your databases. In particular, you have to think about what kind of software orchestration frameworks like LangChain or Cas.io. This is the open source software that we provide to help out. And then last but not least, you have to think about operations. And so at a high level, the generative AI architecture is your application is talking to an agent like a chatbot. Your chatbot is pulling data as prompts come in, you're pulling data from your vector database and then putting that into a prompt and then calling the LLM to summarize or extract information and return it to the user. And to give some people a context about vector search, this is a mechanism by which you can query unstructured data. And the way it works is that, first of all, you map the data into an embedding space. So this is what you mean by that is you take each piece of your data and then you use an embedding model that maps it into this particular embedding space. And then at the time of querying, the query would also map the question to the embedding space and find out which are the nearest neighbors to your original query. And it would use that as the mechanism by which it would populate a prompt. So that's in a nutshell what retrieval augmented generation is. And now I'd like to kick it over to Abhilash, who's going to talk about how they actually got it to work in production and kind of things to think about.
Yeah. Thanks, Aaron.
Take it away, Abhilash.
Yeah. Let me share on the screen. So yeah, just to set you some context on the demo itself. So the agenda around this being, we'll first go into the surface level architecture of SkyPoint AI, and then we'll go into actual hands-on demo, and then where we'll look at different types of data sources that SkyPoint AI is able to tackle and answer and gather insights from. And then we'll come back and we'll do a deep dive into the type of data sources that we support and what goes into actually making an enterprise grade generative AI app. So starting with the surface level architecture. So in an abstracted point of view, it's a 3-layered architecture. Sitting at the core is the SkyPoint MDSP, which is the lakehouse or the data warehouse in legacy terms. SkyPoint AI actually interacts with SkyPoint MDSP and gathers the insight that it needs. And to understand what SkyPoint AI need to gather, it actually gets from the activation endpoint. Activation endpoint can be thought of as a distribution channel. So right now we support 3 of them, one being ChatGPT plugin, the other being UI catered specifically in SkyPoint MDSP platform, third being chatbot on Teams. So and we'll be supporting a bunch of more in the future. So that's the surface level architecture. And now let's go into the different types of data sources that SkyPoint AI supports. So deep diving one level further, there are 2 types of data sources. One is the structured data source, vis-a-vis the dimensional facts and dimension tables that a traditional warehouse has. And this is stored in SkyPoint Lakehouse. Whereas unstructured data sources could be policy documents which could be PDFs, docs, text file, or JSONs. So, and type examples could be HR policies, new hire policies for a particular organization, grievances and rights, and insurance policies. So, from a abstract point of view, when SkyPoint AI gets a prompt, it has a planning phase which decides where it could get the insight from for what user is asking for. That is what we call as intent. So based on the intent and what SkyPoint AI knows about what the structured and unstructured data source contains, it is able to plan and route the query into the appropriate data source and fetch the answer from that. Now, I'll hold off here and we'll go into the hands-on demo. So I'll be demoing from one of the distribution channels that we have, which is the SkyPoint plugin in ChatGPT. So, and to set the context on the data source itself, so it's a senior living data source. So it has data about communities, their review data, their process sentiment data, their finance data, and their occupancy data. So, and this forms the structured data source, whereas unstructured data source could be research documents, annual, which could answer cost of care and forecasting for various types of revenues that you could generate from senior living. So let's start with a structured example. So if I take a very simple prompt, like what is the number of beds for each community for a senior living operator? I'll just fire this query, and so as you can see, the query is passed to SkyPoint AI, which is right now doing the planning phase, basically deciding which data source can answer this query. Yeah, so it was able to generate a SQL query for this particular prompt and fetch the response. And as the prompt asked that in tabular format, it has returned that in a TSV format. And now ChatGPT intercepts it and represents it in an actual tabular format. So this is a structured data source example. If I want to query, say, forecasting documents for what is the, or historical documents for what is the annual cost of care. So this is an unstructured example. So similar flow, it is passed to SkyPoint AI, which is doing the planning to figure out which data source can answer. So yeah, so it has answered, it has fetched from one of the documents that the annual cost of care is 54K. So this covers the two types of queries that we support, and we are actually improving the planning phase to support more complex type of planning, which could be decomposing the prompt into both structured and unstructured, which is a future work. So now that we are, let's dive deep into each of these queries, how they are actually broken down and solved by SkyPoint AI. So coming from this particular data model, I'll refer to this for the structured example. So there's a traditional retail data model where with transaction sitting as a fact, and there are a few dimensions: customers, products, department, and date. So say if I want to query revenue generated by every product category, a user uses a appropriate distribution channel like ChatGPT and fires this query. The query is sent to SkyPoint AI, which actually does the planning phase and figures out that this can in fact be answered from the structured data source. Now, once it has figured that out, it becomes a text to SQL generation problem. So how to do this? So a LLM is capable of generating a SQL query, but since here the data model can be very dynamic, we need to follow a thought process pattern called React to solve this. So what is a React thought pattern? It's an evolution of chain of thought pattern where agent has access to external input, which it can gather information from as observations, and then try to reason about and generate the right SQL query. So in this particular case, an external observation could be the tables, the columns, and maybe additional metadata about the columns, like data types, etc. So in this particular scenario, the agent would basically figure out that transaction and product are relevant tables out of the 5 tables that we saw here. And Then it would figure out that product ID needs to be joined with ID field and then grouped by category, and you aggregate on the amount field. So this is all done through this React thought processing. And for guided generation, it is very important that we have business context, data model context, and historical example injected based on the prompt dynamically at runtime. For that, we use a vector DB like Astra to inject those contexts so that it has enough business context in to guide and generate the right SQL query. Coming to the unstructured example. So for example, what is the leave policy for new hires? So when SkyPoint AI intercepts this prompt, it first plans and figures out that it in fact can be answered from the unstructured data source. And SkyPoint agent performs a pattern called multi-query RAG, wherein it rephrases this query into two other queries. And this is particularly done intuitively to increase the surface area of the documents it can actually cover and fetch into the context of the LLM, so that the LLM can reason with more information available. So for this particular question, what is the leave policy for new hires? Hypothetical two more questions could be, what is the leave policy for new joiners? Because that's a synonym. And the other question could be, what is the HR policy for new hires? So a HR document residing here could have a particular paragraph that could contain this answer. So, and for multi-query is a high throughput use case. So you are basically converting one query into three. And given that you can have thousands of prompts coming in, it's 3 times those prompts. So latency is very important. So a good vector DB like Astra is imperative, which is highly scalable and available. And with that, we have covered how a structured querying works from a generative AI conversational context, as well as unstructured querying works. Yeah, thank you.
Can I ask a few questions, Abhilash? Can you go back to do you mind going back to the structured query portion? And I just have a couple of questions for you. Yeah. So when you go to the structure, so you're doing multiple things at one time, right? So you're first figuring out whether it's structured or unstructured. Then you're trying to figure out what are the transactions, what are the tables to hit. Can you tell us a little bit how an LLM is involved to actually reason about these kinds of, how do you use an LLM to figure out all these, give us a little bit more explanation of how LLM factors in.
Okay. Yeah, so agent continuously interacts with LLM to reason about the next step that needs to be taken. So to start with, when an input prompt is intercepted, the agent injects the relevant instruction required, and a good instruct LLM is imperative here, which can follow good instructions and context given to it. So in this particular scenario, the instruction that could be added as you need to behave as a senior living SQL agent, and also it can add more context, like what a product means or what a transaction means and what it needs to do with each of the fields. So those are added as it's a prompt engineering instruction that is added beforehand. And once that's the first part of to bootstrap the React pattern. Once it starts, then agent continuously follows a chain of action, observation, and thought. So the first thought is injected while bootstrapping, and that could be something similar as, I need to look at the tables available to me. So it would list all the 5 tables, and then that observation is then passed back to LLM, and LLM decides based on the previous instructions in its context and the current list of tables. And hypothetically, in this case, it would decide like transaction and product are the two tables that is relevant for this particular question. Then it would use another action, and that would be looking at the schema of these two tables. So now that it has selected the tables, it would use the agent basically augments the LLM and connects it to the external observation that it can look into. That's the whole point of the agent here. So it will fetch the schema for these two tables and then pass that to LLM. And LLM also has access to all the previous thought processing it has done up until now. So it looks at the schema and now it understands like product ID and is a foreign key to ID here. And it takes the first pass at generating the SQL query. It may be right, it may be wrong. If it is wrong, that it tries to refine it continuously. And that is also done through action, observation, and thought chain. So that's the whole React pattern in a nutshell.
So how many, let's say in the case that there are no errors, how many LLM calls are there in total for this entire chain?
It would be 3 LLM calls. So the first LLM call for listing the tables. First LLM call is for listing the tables when you get the list of tables and pass it to LLM. The second is for schema listing. Third is for SQL query generation. And in fact, and once the SQL query is generated, it just fires that SQL query to the warehouse. I mean the agent in this context. So in best case, it would be 3 calls.
Doing all these operations and it takes a lot of time, right? So like, what are some of the things that you did in production to actually reduce the time, the latency for these entire transactions?
So one thing we did was to inject the thought traces itself along with in the bootstrapping instruction. So it has access to a lot of information, and these thought traces were stored in a vector DB like Astra. So based on the prompt, it injects close enough thought traces in the context of that particular prompt to the agent itself, so that it can skip some of these schema table listing and schema listing step and directly jump to SQL query generation. So in certain scenarios, it skips
you're using
those
the vector database. You're using the vector database to kind of, in some sense, cache all these LLM calls to reduce the number of calls to the LLM. And this is really important for reducing the latency, because everybody knows when you're calling the LLM, it's very slow. Wow. So you're using, in this scenario, using the vector database for caching the LLM calls by putting thought traces, and you're using the vector database to store few-shot prompt examples for calling the structured tables.
Yes.
Okay. Wow. Okay. Well, that's a really very cool use of the technology. Well, why don't we switch it over to Tissen? And this technology sounds really awesome. I'd just love to hear kind of like what's your vision of how these LLMs are going to transform the healthcare space.
Absolutely. Thank you, Alan. I'll share my screen and kind of go through some specific examples that is in long-term care. So to kind of set the context a little bit, in the United States, the government spends about $750 billion a year on taking care of the most vulnerable population in the United States, whether it could be people who have very low access to care, Medicare and Medicaid programs. So we have focused quite a lot of our energy on building data, AI, and BI solutions to really drive the cost of administrative processes and cost of care down. So if you think of the amount of money of that 750 billion that is going into actual clinical care, is probably around 1/3. Rest of it is going to paperwork, administrative processes, regulatory compliance, wasted money on shuttling between 5 different layers of companies and processes before the dollars reach the actual patient itself. So I'll kind of show an overview of the area that we are particularly focusing on, which is in long-term care. So let me share my screen here a second. I'm going to do an entire screen share here so I can pop this open here. Can you guys see my screen, hopefully?
Yep.
Okay. So what this is what we call ourselves as an industry AI platform, which is an AI stack that is very specific to the long-term care industry. So that includes post-acute. Post-acute is when someone is discharged from the hospital, they have a chronic disease, they are actually going into a skilled nursing facility, or this could be a surgery, things like that. So rehabilitation, long-term care. So this is a space we are putting a lot of focus on. So as
I just want to also just double check I got the numbers right. You said only 1/3 of the money is going into the actual care, and then 2/3 is going into administrative stuff that really should be automated by a computer. Is that right?
Yeah. This is the layers of, government. It's a government paid service, and the layers of companies in between the government and before it touches the actual patient is ginormous. So each layer adds administrative burden. For example, a PBM, different types of payer arrangements. So that's why the government is really working on how can we kind of surpass these middle layers. Obviously I come from Amazon. We were all about getting, cutting the middleman out, right? So only technology can really cut the middleman out. So if you can cut the middleman out, kind of enable organizations to be highly more efficient, then their administrative burden comes down, and the more dollars will go into actual care, to doctors who are getting burned out right now, or to pharmacy or hospitals. Most hospitals doesn't make money in the United States. Most of them lose money. So this is like not a nice to have. So without AI and technology and data, our system will implode. So this is like what we need for this thing to even actually function. So yeah, great question. So if you look at this overall, so this is basically the three layers. So one is that unified data sources that we talked about, structured, unstructured. So that's where Astra comes in, and you have data warehouses or databases. So external data that is coming from CMS, and knowledge graph of who's doing what. So that's what Abhilash was talking about, is that centerpiece where our AI is built for value-based care and senior care. On the right side is where you can interact with the AI using English. So this could be somebody who's administering a skilled nursing facility, or somebody who's a clinical director. Currently, what they have to do is they have to submit compliance tickets. They, even to access simple things that is sitting in EHR, they have to open 15 different screens and then make sure that whatever they're trying to do is compliant, right? So all of this takes enormous amount of administrative burden. So the healthcare word, they call it as a pajama time, So it's really not, you're not treating the patient. So essentially these things, making healthcare data conversational. This mission is as big as probably Google's mission of, organizing data to make it accessible and useful, right? So there is a lot of data out there, but it is not accessible. because it just needs layers of IT to deal with, or it's neither useful because it's old, it's not timely, you can interact with it. So we have a few examples here that I think Abhilash touched on. Is data sitting in an EHR system, human resource system, data warehouses. So where this is a prompt, what is the total overtime hours split by job role? This is a very important one because the way staffing and scheduling works, if you look at scheduling inside healthcare systems, it's just really complex. They either understaff it or overstaff it. Both are bad, because if you understaff it, people are not going to get the care that they want. If you overstaff it, and obviously people are getting burned out, you're paying overtime, and just overstaffing doesn't really mean that you're getting the care, which basically creates more administrative burden. So that is, these kind of queries around, what's the time when you are actually using these overtime labor or temporary staff, things like that. So there's a lot of prompts that we are seeing in the real world with our customers that are very much centered around, how to reduce cost of care, how to improve efficiency of labor. On the right side, it's, there is a lot of multimodal interactions. There is a lot of compliance document, there is images, so think of healthcare as enormous amount of unstructured data. So for example, we get a lot of questions around infection control policies. What are the patient's rights? Hey, I'm dealing with this situation, what should I do? So this is coming from clinical, administrative, clinical people, and also payers interaction. So we have a few examples here in terms of what are the real world use cases now our customers are seeing enormous value. One is question answering without having to deal with IT. So it sounds simple, but even if 50% of your questions from a business user, it doesn't matter, it is clinical, non-clinical, compliance, whatever, can be answered by AI without going through the layers of IT, that's an enormous win, because a lot of times the business users' questions change a lot. So before AI or Gen AI, it used to be you have to write down all of your requirements, you have to wait for IT to wake up, then they basically code your stuff and then gets back by the time the requirements changed, right? So that cycle time was just too much. And then on the other hand, IT teams are frustrated because business users change their questions all the time, their requirements. And first they come up with some questions or things that they need to get done. By the time IT gets around to producing the results, the requirements change. They're frustrated, like, okay, you asked me to do this, a month ago, now you change your mind, right? And there's a lot of one-off reports and one-off work that only one time gets used and never get used again. So essentially that question answering in plain English, even if in our scenarios, even if 50% of questions can be answered by AI with a combination of structured and unstructured, without relying on IT, that is probably billions of dollars of productivity gain right there. So that itself is a huge win. It doesn't have to be 100%, even 50%. The second one is around care teams, which is a lot of questions, obviously from family members and loved ones about, their people who are in a skilled nursing facility or a senior living facility. So constantly questions. So essentially you have to look up documentation, respond to them. So this can be cut down by generative AI, just really pulling data from a warehouse or an EHR system or a payroll system, whatever, and combining that data with, that's what Abhilash touched on, that combo queries. We're checking for compliance, checking for documentation, pulling that. This is basically customer service. And the third one is the resident experience or the patient experience itself. Is most patients want to access their own information. So if we can extend these capability to the patients themselves or their loved ones and their family members to check on, hey, did mom or dad or grandparent, are they doing well, with their medication? So yesterday I was doing a demo, and so this large provider, they have almost 900 to 1,000 skilled nursing buildings. So they were asking questions about what's the likelihood of these residents getting rehospitalized So AI answering those questions, because it was a struggle otherwise. You had to go to a report of what is a likelihood of rehospitalization. So everything was segregated into different applications, so that the interface wasn't that good. So as we kind of see these enhance of the customers, so we are seeing a lot of productivity use cases where 20% of the work is getting 80% of the value. So essentially, some of these examples I showed you. Can you write an email to residents' family member about infection control policies? This is completely driven off the SkyPoint AI agent and Astra, essentially what Abhilash just touched on. So, hey, here is a nice email about infection control. This constantly asked question is based on who, and explain it to somebody, in a different language or whatever that is. And then clinical and population level questions, analyze the vital signs of elevated levels of pain. So this interaction that I'm showing, conversing with your healthcare data, this is really EHR data that is coming from the EHR itself. But without a conversational AI, trying to get to this information would have taken so much time. Either logging into the EHR application or going to a report, trying to do all of this, and then providing that information back. So, and there is obviously financial questions like this. So we are seeing a lot of FP&A type questions, reducing the cost of care, improving the quality, ratings, things like that. And then this is basically, patient level questions. What is the insurance details? What is, the vital signs? What are the rate trend changes? And last one, this is the most important one. I think this is what I'm really excited about, is the combo prompts, where, hey, can you create a care plan for a particular patient, right? Based on their health state, regulatory policies around it, boom, here you go, right? So that is like, so if you think about the first phase, answering questions around structured, unstructured, and all of that, that is a phase 1 or horizon 1. And this is horizon 2, is where you have AI creating care plans, how do you do scheduling, all of these kinds of things through generative AI. And the third is basically going into autonomous agents. That's even the level next to that. So essentially, these are real examples. Obviously, we have the names and everything de-identified, but they're real examples of production level customers interacting with SkyPoint as we are going through the different, the crawl, walk, and run of generative AI, where the first they subscribe to our platform, then we do a POC or an MVP, and then we decide how we roll out each of the use cases to their users. So essentially, it's a very methodical step-by-step process to make sure that all of the security and privacy compliance is in place, and it is rolled out to the right people at the right time, and all the education and training. And the feedback we are getting is like so many wow moments. This is awesome. This is amazing. This is so much different than what I was doing. It's like a 10x difference. Not like, oh, this is a little bit better than what I was doing, right? So that's what we are super excited about, and we are super happy that we're partnering with DataStax into making a difference in healthcare using AI.
Well, I'm just blown away, Tisin. I look at my my children's world, and I ask myself, what are the 3 biggest threats to their future? Nuclear weapons, climate change.
Yeah.
But the third is our aging population, right?
Yeah.
We'll look at and just to the audience, the aging population is going to be doubling and tripling over the next few years. So like literally in the next decade or so. And if we don't remove that 2/3 of administrative waste, like literally people are not going to be able to have care. And that's going to create a huge amount of civil unrest in our society. So I really, I'm very thankful that you are taking this upon yourself to actually solve this mission. And it's amazing that we can actually use generative AI to do this. So probably more useful than generative AI TikTok influencers.
Yeah, for sure.
Thank you.
Yeah, and our customers are really supportive of this. They're leaning in. That's what we are seeing. In the last few months, I've been involved in one way or the other, probably 75 to 100 demos with different customers. We have a lot of customers signed up. and paying for our product, they're really leaning in, Alan, to make a difference. So they know this can make a difference, and this is not like a shiny toy, So this is something real for them to make a difference in their business. And this is a long game. They definitely know that too. This is like the dial-up stage of the internet. So they know that what this can deliver to them in the long term. So I'm very happy that our customers are leaning in as well.
Cool. So we have I'm going to ask you a few questions. And by the way, the audience, please feel free to ask questions. And as you ask questions, we'll type in the answers. I just want to get some best practices and tips here. So based on the use case, you can't make errors, really. This is going to affect people's lives. So what are some of the ways that you use to reduce hallucinations, Abhilash? If you can tell us some tech tips to use to do.
So there are a couple of ways. So as I mentioned, in the case for structured as well as unstructured, you can have a validation layer, and that could be part of the React pattern as well. And that's what we are also doing currently. So we reverse map the answer to figure out if it in fact is answering the question or not. So for example, if there is a SQL query generated, you reverse map it to the conversational space. So ask LLM to give you two questions that this SQL query can answer, and check the intent between the input prompt and these two prompts that is generated from the SQL query to figure out if the intent matches. Otherwise, there is something wrong. Even though the SQL query is syntactically correct, it's semantically not answering the question, then it's no point, right? So those are some of the ways. And the other way is you can actually fine tune the React pattern itself. If you have enough thought traces, you can actually fine tune your model to be more deterministic on what steps to take, because there are some hallucination that may happen where it takes the wrong step at the wrong time, and due to being influenced from some other prior step, and that could cause into a factually incorrect answer. So you can reduce all of these things by fine tuning as well if you have enough thought traces.
So when you say fine tune, you're taking the thought traces from the customers that that are right, and then you're adding the fine tuning procedure on the LLM itself, like using the OpenAI's fine tuning APIs.
Yes.
Oh wow. Okay. So where are you storing your thought traces at the moment? And can you kind of describe a little bit about that workflow? Like, how do you validate that the thought traces are correct? And can you kind of validate that workflow for me?
Yeah. So initially, when we created this validation layer, it was not at runtime. It was validating if say a SQL query or a RAG answer is in fact answering the question. We were actually looking at the traces that we are logging in our infrastructure to figure out for every thought trace. We were actually doing this labeling process, and that's where we created this validation tool, which was actually looking at the intermediate steps to figure out if, like for example, in structured case, look at the SQL query to figure out if it is actually answering the prompt asked by the user, and then we were labeling these examples as right or wrong, and if they are right, we are actually collecting this as a corpus, and once we have collected this, then we tried fine-tuning our LLM.
Interesting. And you're using LangChain at the moment for doing some of this orchestration?
Yeah, we are doing LangChain. So they have a lot of callbacks that you can configure. The default callback is logging. You can actually add more callbacks so that it actually can publish the thought traces anywhere. So our thought traces are available to us since we are heavily on Azure on App Insights, and we publish it there so that we can actually do downstream processing on that.
Interesting. Okay. Do you have any kind of tips and tricks about like when when the user complains, or like how are you dealing with when things go wrong? Actually, can you give us some, like, what's the path of you debugging your application production?
Yeah, so that's a separate workflow. So for that, we actually store the historical examples in Astra. So as users are typing prompt, those continuously go into a backend process that pushes it to Astra. And when a similar prompts come in, it actually looks at the most recent example from Astra and injects that. And also, if there is a user input, which is currently only possible from SkyPoint AI user interface, based on that, we decide if the Astra example historically needs to be invalidated or not. So that's how we decide what examples are actually currently correct or incorrect. So
Great. Well, maybe one last question to you, Tissen, to all the LLM app builders out there. Do you have any thoughts on, from a business standpoint, a CEO standpoint, on how they should go about building their apps and engaging customers?
Absolutely. I think it's don't boil the ocean. Don't try to go, it's like enterprise-wide strategy or anything like that in the beginning. It's always good to have that. I get a lot of questions from the CEOs of companies, how to approach generative AI. Should we hire a consulting firm to interview everybody in different departments? So there is a lot of like, how do we get started? What I would say is, rather than sitting around and waiting on the sidelines, kind of build your strategy. Pick a business unit or pick a use case. Start with something and create a proof of concept of an MVP that is of a real economic value to your organization. So for example, within our skilled nursing providers, they have all kinds of different business units and difficulties to deal with. So for them, they usually start with knowledge management, compliance, something like that to get started, and then have that interaction, and then show it to your end users that, hey, this is something of value. And then that's a kind of the crawl phase. Then you can walk to other departments, and then you can kind of have a higher level roll up to the board and others about what it can do. So the boil the ocean approach is basically slows everything down, everything becomes a committee decision, and too much IT involvement on, let's go, we are going to select the best LLM. Let's do that process for like 3 months, and then we are going to do another RFP for vector. By the time you're done with this, it'll be like a year. So, and you haven't learned anything. So I think getting started, showing value to the business, putting it in the hands of your users, and then kind of developing that to your organization. It's a much better approach that scales well because you're learning from your own examples. And I think most organizations now, the leading companies, whether it could be Google, AWS, Microsoft, they have good responsible AI frameworks. There is good safety and guardrails and these things in place. So I think it is. So my recommendation would be to get started. For the organizations. Yeah.
Well, thank you so much. I think that is the end message. Let's just get started. Let's get things in production. Let's learn. So Thank you very much, SkyPoint. It's been great collaborating with you, and we hope to see the great things that you're going to do in impacting the elderly care space. Thank you.
Thank you so much. Thank you both.
Thank you.